Hi all, this video will help you to determine the mathematical expression x of t for your half-wave rectifier or full-wave rectifier output, which is given graphically. So consider this signal. For this we have to find the trigonometric Fourier series. If you want to find the trigonometric Fourier series, you have to find x of t in mathematical form. You have to find t naught, you have to find omega naught, then the Fourier series coefficient a naught, an, bn, and then finally x of t in Fourier series representation. So if you observe this signal, it resembles the sinusoidal waveform. So once the first portion of the sinusoidal waveform is present between the time period 0 and pi. So to obtain x of t for this signal, we have to find the expression x1 of t, which is nothing but the regular sinusoidal waveform with the fundamental time period 2 pi. Okay, why we are considering this signal is here the first half ends at pi, so this is the first half matches with the given signal, and we are extending this sinusoidal waveform to an extent 2 pi. So now we forgot about that x of t. First we will solve x1 of t. So in solving x1 of t, the general format is x1 of t equal to, first you have to mention the amplitude. For this signal, amplitude is mentioned as a. So x1 of t equal to a sine omega t. Don't confuse this omega with that omega naught. This is different and that one is different. Okay, so you have to find omega for this signal, and if you replace that omega here, then you will get the expression for x1 of t. Okay, what is the formula for omega is omega equal to 2 pi f, which is equal to 2 pi divided by capital T. So t is nothing but the fundamental time period for this signal. So here this is considered as one cycle. So the one cycle time duration is 0 to 2 pi, that is 2 pi minus 0 equal to 2 pi. Okay, so since t is equal to 2 pi, we are just substituting that value, 2 pi divided by 2 pi, which is equal to 1. So the unit is radian per second, so you can leave that. Okay, so the x1 of t expression is simply noted as x1 of t equal to a sin t. Okay, so we found x1 of t, which is a sin t. Now we need to find x of t, which is the required one to find the Fourier series. So to find x of t, x of t equal to x1 of t for the range of t is greater than 0 and lesser than or equal to pi. Okay, we need to bother about only this region 0 to pi. Okay, so this period only, this portion only continuously repeating and form the entire waveform. So here this portion is considered as cycle. This portion is considered as cycle for this waveform. So this is one cycle. The x of t need to be calculated for one cycle. Okay, so here I am just replacing the x1 of t by the calculated term. So x of t equal to a sin t for t is greater than 0 and lesser than or equal to pi. Okay, so this is the required x of t for finding the trigonometric Fourier series of the given full wave rectifier output. Okay, so we found x of t, then we need to find omega naught and t naught. Okay, forget about this omega and t. Here we need to find omega naught and t naught. Okay, so first we need to find the t naught value. As you know, the t naught value is nothing but end point of the cycle minus the starting point of the cycle. Okay, in this case, the end point is nothing but pi, and the starting point of the cycle is 0. So here it is pi minus 0, which is equal to pi. Once you find t naught, we need to find omega naught. Omega naught is equal to 2 pi by t. So which is equal to 2 pi divided by pi, which is equal to 2. Here you know the unit of t is equal to seconds and the unit of omega naught is equal to radian per second. Okay, so if you found omega naught, t naught and x of t, it is easy to find a naught, an, bn using the formula mentioned. Once you find a naught, an and bn, you can easily represent the given signal in Fourier series representation by just substituting the a naught, an, bn value in this formula. Okay, so if you want to check the value of x of t, you just substitute the values of t. For example, if t is equal to 0, for t is equal to 0, sin 0 equal to 0, so a into 0 equal to 0. If t is equal to pi by 2, t is equal to pi by 2 is nothing but this point. Okay, this point is pi by 2. So if you substitute t is equal to pi by 2, then sin pi by 2 equal, let us consider the halfwave rectifier output waveform. So the halfwave rectifier output waveform will be like this. So we assume the amplitude is equal to A. So before finding x of t, we are just finding x1 of t, since this portion resembles the sinusoidal waveform. Okay, so we already calculated x1 of t. The same x1 of t we are using. X1 of t equal to a sin t. This is what we calculated. Okay, so if you refer this waveform x of t can be simply written as x of t equal to x1 of t if t is greater than or equal to 0 and lesser than or equal to pi, and the value equal to 0, x of t value equal to 0 for the value of t is greater than or equal to pi and lesser than or equal to 2 pi. So the x of t is fully represented with the mathematical form. So if you substitute this x1 of t value, then x of t equal to a sin t. For t is greater than or equal to 0 and lesser than or equal to pi. Okay, and 0 for t is greater than or equal to pi and lesser than or equal to 2 pi. So in the process of calculation of Fourier series representation, we found the x of t value. The remaining things are omega naught and t naught. So you know t naught value equal to ending point minus starting point. So in this case, what is full cycle here means the portion starts at 0 and ends at 2 pi. This portion is called as one cycle. Why? Because if this cycle repeats continuously, then only the entire waveform will be generated. Okay, so don't consider this alone a cycle. We have to consider the range 0 to 2 pi. Okay, so the ending point is 2 pi and the starting point is 0. So the value of t naught is obviously 2 pi. Once you find t naught value, it is easy to find omega naught value. Omega naught value is nothing but 2 pi by t naught. In this case, 2 pi divided by 2 pi, which is equal to 1. So we having omega naught, we having t naught, we having x of t, so we can easily find a naught, an and bn value. If you got a naught, an and bn value, it is easy to determine